Okay, so now we're going to go on to finding information and processing that information, filtering that information. But before we do that, we just got to look at the different sorts of information slash literature that's available to you. There are a few different categories of information. One is textbooks. What do textbooks do? Well, they typically are more general. They consolidate all the information that's been done from research over a number of years and give you an overview of a subject matter area, like, say, for example, software metrics, or maybe health information systems, electronic health records. They can be useful because they give you an overall structure to talk about a subject in. They're individual chapters, they're individual sections giving you that structure. The individual chapters go deeper into individual aspects of electronic health records or software metrics, so that's good too. You can go a bit deeper. And typically at the end of those chapters, there are references that allow you find journal articles, conference articles, the other article types that you see on this slide, so that you can dig deeper into the subject matter material. So textbooks, I often consider them as a gateway, a good starting reference on your subject matter material. So say you're interested in software metrics, the example I'll use throughout the lecture, then a textbook on software metrics is a great place to start, giving you the structuring of how you might structure your article, deeper chapters on topics that might be of interest to you, and gateways to further material that might be of use to you. The downside slightly with textbooks is that they're a bit dated because they've had to consolidate all the literature. Once they've consolidated it, they've got to write the book, which takes a number of months, maybe even years, and then they've got to have it reviewed and edited and accepted for publication. So that might take even longer. So they are maybe a bit dated in their recentness. Another type of article that you might be looking at as you do your dissertations and as you walk through the masters are journal articles. Journal articles are essentially academic magazines where you have a cover-to-cover magazine and it's split into several different articles, each article reporting on research work carried out by a number of researchers. They're typically very hard to get into. You submit to a journal and then you wait as 3 reviewers review your article for maybe 2 or 3 months, and they'll come back to you and say, sorry, it's just not good enough, or yeah, it's good enough, but we need certain changes before we consider publishing it, or very rarely, look, small typographical errors here and there, we'll proceed to publish it. Usually you get the second sort of category, so the experts that peer review your article demand a lot of changes from you. In one case, it took me over 2 years from the date I submitted it to the date of publication for a journal article. That's how many changes they wanted. So after you get the feedback saying that they want changes, you endeavour to make these changes and submit it again, and then it goes out to the review panel again, and they might ask for more changes now that the article has changed. And that's what happened in my article that took 2 years. It went through several iterations of change. I like to think in that case it was because the article was kind of important. The article has since had a high citation record. A lot of people have cited it. The reviewers knew it was going to be an important paper and wanted to get it even righter than a lot of journal articles, but 2 years is still a very long time to wait for publication. So what does that profile tell you about journal publications? It means they've gone through extensive peer review before they've been published, and that means they're typically of a very high quality. They're typically state-of-the-art research, so they're in-depth research. So while textbooks may give you the broad overview, journals let you go deep. But of course, they can be reviewed for a long period of time, and that's separate to the amount of time it took to write it up in the first place, and the amount of time you've taken to correct the reviewer's comments, and the amount of time taken to carry out the research. So by the time it gets into a journal, the research can be a little dated. So the characteristics of a journal article are essential truth as believed by the academic community, a group of your peers, but maybe a little dated. Another valuable source of academic material are conference articles. Conferences are where computer scientists or health practitioners get together for a meeting. They typically pre-submit papers to that meeting. Again, they go through a review process, and the reviewers decide if they're acceptable for the meeting, and if they're acceptable, what changes need to be made before it's presented at the meeting. So conference articles are papers that are included in the proceedings of the conference, a book of proceedings, book of articles in the conference. They have been peer reviewed, but only once. The conference has to go ahead on a specific date, so you get your reviews and then you make the changes ideally, but no one checks that you did those changes or the standard to which you did those changes. As a result, conference articles are slightly more timely because you submit for the conference deadline and the conference goes ahead about 4 or 5, 6 months later. So if you get published at all, if you get past the review stage at all, you will get published, and it'll only be 6 months or so after you initially submitted the article. So they're a bit more timely, but they're a bit less trusted because there's no guarantee you did the reviews to the reviewer's specification. So that's how conference articles differ from journals. The third category of article we're going to talk about is workshop articles. Workshop articles are like conferences, places where researchers go to present their work, but these have more of a flavour of new ideas that might be interesting, that haven't really been established evidentially yet. So you might have done a small pilot study on this idea you have, but there's no real proof that it works yet. It's the interestingness of the idea that gets you accepted or not into a workshop. So again, you write the article, you submit it to a workshop. It gets reviewed by 3 reviewers who are more so focusing on the idea rather than on the evidential truth of the idea. And if they think it's an interesting idea that will stimulate discussion at the workshop, you get accepted. Again, the reviews are sent back to you and you should make those changes, but of course you don't have to because it won't be reviewed again. It's been accepted for publication. That's workshop articles. So you can see there's sort of trend from depth and truth in journals to more ideas in workshops and less evidence behind them, and conferences sit somewhere in the middle. So these are considered the highest quality, if slightly dated, academic work. Less dated, slightly less established truth conference articles, and much less established truth workshop articles, but more timely and very current. These are the ideas we're coming up with at the moment that might form research agendas in the future. A fourth source of information is posters. Now, typically you can't really find these in libraries, but if you go to a conference, researchers who haven't got accepted maybe to the full conference or who have interesting ideas but there's no workshop, it's a conference, get to set up an A3 poster in the foyer, stand by it and talk about their ideas to conference attendees as they go by. And you can get really current ideas there because this is basically a stage where you've got a poster together but you haven't even got a workshop article together. There is other material as well, and it's called grey material. It's not considered academic material in that it's not produced by academics. It's more populist, I suppose is one way of looking at it. More practitioner orientated maybe. Notes from meetings, that sort of stuff. And this material is seen as not so strongly evidential in basis, not so academic, but it is included in a lot of dissertations and PhDs and master's theses. So I suppose again the idea is that you don't make statements when you're writing saying this is established fact if it's based on grey material, if it's based on opinion articles or the like, whereas with textbooks or journals you can sort of say, well, it's been shown that. Conference articles, you can probably use that phrasing as well. Workshop articles are probably it's been suggested that. Likewise posters and likewise grey material. Okay, so moving on to actually finding the material then. Well, where would you find resource articles that you can use for your research work? Obviously the web, but our first port of call is going to be the library. So we can either click on the link in the web page to bring it up, or we can just go to UL and find it that way. Let's do that. So here we are in the Google homepage. Let's just go worldwideweb.ul.ie. And if we go to staff for students, you'll see there's a link down here. I've made my screen kind of small so it fits in the pane that I'm recording. So I'll have to do a bit more navigation than you probably would. In fact, the best place to go to it is library.
Okay, and this is the library homepage. You can see there's quite a lot of stuff there. What we're going to concentrate on doing first is typical sort of user requirement, finding a book. So let's search for a book. Let's do one for the health informatics students first. Electronic and we do the search. And you see a list of books comes up. List of books that you can expand. And you can do things like see their location in the library. You can get any notes that come with them. There aren't general notes with this, but there would be notes with other ones. So you get a fuller view. You might notice this here is that's a location tag in the library. So you notice 651 there, for example. That's a shelf number essentially. And you'll notice endnote.web. This is a facility that allows you to take the reference automatically from here and put it into your EndNote library. We'll talk about that more when we get to talking about EndNote later on in the series of lectures. This reference library tool that we talked about. So just taking a look at all these shelf numbers, you'll see that they all seem to fall into two different spaces: 610, 610, 610, 610, 651, 651, 610, 362, 651, 651. So that tells you if you're interested in electronic health records, you should be looking at shelf number 651 or 610. Now these shelf numbers, they're difficult to get your way around. The only way to find them is basically go look in the library. They are contiguous, but sometimes you may get unlucky and the shelf numbers stop for one series of shelves and then you have to go to another section of the library to continue on. But once you found them, they're there for every book you'll probably want. Okay, so let's go back and let's try something more software engineering-y. So what do we try? Software metrics, I suppose. And software comprehension. If we go look for that, we'll see that actually, because we're looking for books, we get some books like Advances in Software Engineering, Comprehension, Evaluation and Evolution. But we also get some UL books, some theses that have been produced here. So Brendan Cleary had a PhD thesis under my colleague Chris Exton, and that book is there because software comprehension is in the title. Likewise, Conor Hughes' MSc thesis is available, and software comprehension in concurrent and parallel systems. Pamela O'Shea, another student who did her PhD under Chris Exton, investigation of views and abstractions employed by software engineers during software maintenance, and empirically founded set of guidelines for visualizing tools supporting software comprehension. You'll also get books of proceedings, so the third international workshop on program comprehension, which has a series of articles, and as you go down they get slightly less relevant. Again, you'll notice though that these things seem to be in exactly the same places. So the thesis seems to be in the thesis library. The software comprehension articles seem to be in 005.1. So if you're looking for software comprehension, you're looking at 005.1. This is kind of interesting because typically if you go to a supervisor and say something like, I'm interested in program comprehension, Jim, they might direct you towards one of their students' thesis, or maybe Pamela O'Shea's thesis, for example. So you can find those theses by restricting your search to, restricting your search for a book and putting in software comprehension up here. So this allows you to get the books. Alternatively, a supervisor might come along and say, actually, I had a paper written by that with one of my students, and so searching for a book won't find that particular paper that was submitted to an academic journal. So you can search the UL research repository. You can find all the papers and theses that have been written in a specific area. So this is Tara Kelly, one of my PhD students who looked at software comprehension. Likewise, another of my PhD students who looked at software comprehension. So this is a thesis, This is a paper, this is a paper, this is a paper, another paper. So you see you get thesis and papers in that, and of course you can go down pages as well. So that's very useful when the supervisor asks, your potential supervisor says, look, I'd like you to read up on some of the papers that we've written in this area before we discuss what we're specifically going to focus on in the area of software comprehension, in the area of electronic health record security, for example. And now you see we're moving more from textbooks to more deeper knowledge, more PhDs, more journal conference papers that focus on this more specific thing. Okay, so now we're going to look at trying to find research articles on a certain theme all over the body of literature. So everywhere there's anything being written about software metrics, anywhere there's ever been anything written about electronic health records in the academic literature, not necessarily in textbooks but in papers that have been written in any forum. So you could go forum by forum and look for them. So you could look at maybe that international workshop on program comprehension and get articles on software comprehension, but you're missing out on all the articles that have been written in different conferences or different workshops. The way to get around that is to use something called databases. Databases are collections of different conferences, journals, workshops, which you can search all in one go, and we provide an alphabetic listing of them there. There are some more specific to health informatics, and there are some more specific to software engineering. So let's look at the ones more specific to health informatics first. The Cochrane dataset should be somewhere down there. Yeah, the Cochrane library. Now this is for more clinical trials type stuff, but still we can type in something like electronic health record here. And search. And we get a lot of papers, use of electronic health records to support smoking cessation, methods to increase response to postal and electronic questionnaires, electronic health records, cigarettes for smoking cessation. So yeah, there seems to be diffuse articles there, not really focusing on electronic health, I suppose, as you'd sort of expect in a clinical trials thing. But just to note that you can go in to each individual article and get the structured abstract of that from the Cochrane dataset. In fact, you can get the whole article. More use really is when we look at the databases. I suppose Business Source Complete would probably be a good one. So go down there, be at the end, I suppose, of Business Source Complete, yeah. And Academic Search Complete is another one of interest for health informatics type students, but we'll just select all. So that includes Academic Search Complete and Business Source Complete. We'll continue. So now we've got a whole load of databases we're going to look over, and we're going to type in electronic records. Electronic health records again. And search. And here we see we got a load of, in this case it's a journal article, American Journal. American Journal of Health Systems Pharmacy, MIS Quarterly, Management Information Systems Quarterly, mostly about electronic health records. So state and local chronic disease surveillance using electronic health records, monitoring clinical decision support in electronic health records, how can researchers contribute to transforming healthcare. So lots of relevant articles there on electronic health records. And of course you can see the full PDF, so you can download the full PDF and read the actual articles there and download them if you so wish. Another interesting thing is you can also look at the PLUMX metrics. So what is been looked at in that how impactful that article is. So you can see that it's been cited in academic articles twice. It's been mentioned in blogs once, tweets 10 times, captures 36, and abstract views 4,411. So in medical terms, that's probably okay, but there, you probably would be looking for more citations for a really impactful reference article. Business Source Complete is also good for software engineering. So let's type in software metrics there, especially if you include all the different databases underneath Business Source Complete. So you see bug prediction using object-oriented metrics. Where is this? This is in a journal as well. You can tell by the volume and issue number. Computer Science Journal of Moldova, Class Cohesion Metrics for Software Engineering, a critical review. A few non-English ones. Parallel Framework for Software Defect Detection and Metric Selection. So you can see that you can get those sort of articles out of Business Source Complete as well. But there are more specific ones that are probably better targeted at software engineering. So let's go and find some of those. The first one is the ACM, Academic Search Complete. No, sorry. ACM Digital Library. See up here you've got your search space. So if we put in software metrics there, and you'll see that you get a lot of articles. In fact, 142,000 plus, nearly 143,000. So that's a bit overwhelming, and we'll return to that point later on in the lecture. So you can see, again, you can download the PDFs. Here you get a feeling for how important they are. This obviously is a bit more impactful than this one, provided the year. Yeah, so it's a bit older, but that doesn't make a difference between 7 and not. David West would be an influential researcher in this area. Software metrics. So you can basically look at whatever article you want and download them. Okay, I'm just going to tidy up some of these tabs up here because I got lots of them. So let's go. So we're back to here. Let's go back to our databases. Explore collections, databases. It's a phenomenally powerful tool, really, because what you're saying is you can do a pan search on everything with keywords. So we've just done the ACM. We should also do the IEEE. IEEE Electronic Library Online. And likewise software metrics. So we got 9,318 articles. Again, you'll notice a few things about the two different batches of literature. The health informatics, it's more journal-based literature. Software engineering has always had a stronger ethos on conference workshop publication. So it can be as hard to get into a conference in software engineering as to get into a journal, whereas that's not the case in health informatics. So there you see the articles. Again, you can download them if you so wish. So one final database I want to show you is Web of Science. Just to emphasize the point here, you see when you use IEEE Explorer, for example, you're searching 4,296,619 items. So that's a huge scope of searching. It's a huge facilitation to a bit overwhelming, but a huge facilitation when you're trying to find all the academic articles on a specific topic. Okay, let's go to the Web of Science. Web of Science. Again, Web of Science probably is more software engineering than health informatics. So we'll put in software metrics there. And it comes back with lots of articles again. You can view the abstract, or you can go into it and view the full page, the full article, depending on if the library has access to that article. In this case, it doesn't. Interestingly, on the Web of Science, you see the usage count, the number of times it was cited. This was cited once, and it actually lets you view the articles that cite this. Okay, so that more or less concludes our trip around the library. There is one last thing I'd like to mention, particularly for the health informatics students. They'll be typically trying to use the library at home. So there is an Access eResources off-campus facility. So that page there tells you how to log in, sign in, how do I set up a UL computer account, how do I get access through Google Scholar off campus, how do I access ebooks off campus, and how to get help with any of the library's electronic resources. And that site is mentioned in the PowerPoint slides as well there at the end.
So those people who've been really paying attention will have noticed that we seem to be searching for our articles in exactly the same way through all these databases, through the library classic catalogue. We're searching for a term, and that's a decent way to search for articles, but there are sometimes more directed ways. You'll notice that in every article you've read, for example, there's a list of references at the end. So these are the articles that this article you're reading depends on. And if you find that the article you're reading is a really core one for you, you'll probably want to read around that article as well. So you should maybe look up a number of the core references that it uses to make its argument. For example, say this is the Health Information Systems review paper from last week. Say that you found this really interesting and you wanted to dig in some more. Then you would probably go to the end and find some of the core references. And there are a lot in this. I think there's about 80 or something, 81. And you'd probably go look for those ones. So that's sort of chaining from one article onto the next one. It's a good strategy, but unfortunately it means that you go backwards in time, because all those articles that are referenced by that article were written before that article. How can you go forward in time? Well, I mentioned on the ISI Web of Science there, on the library database page, that you could actually use the forward citation tool, articles that cite this article. We just didn't have any of them, which had a citation of greater than 0. But you can also use Google Scholar, which is really a very good tool in general. So let's get out of this and go to Google. And if we just type in Scholar, SCHOLAR, Google Scholar comes up and we can go in there. So, what can we put in? We can put in maybe an article by me. Taxonomy, software change. And there I am in all my glory. You'll see that even if the library doesn't have it, you may be able to get it from somewhere else. See, the library has that one, but these are not from our library. So maybe if you're unlucky with an article in the library, you might be able to download it from Google Scholar. Not all articles, but most articles. If we go into that one, well, we don't even need to go into it. We'll get all the reference material going into it. We'll get the PDF from here. But this is an interesting little element here. It says cited by 270. This is the article that got 2 years, went 2 years through the publishing cycle in the journal. And this, when I click on that 270, it lists everyone else that used this article. So my article is in the reference section of all these articles. And what that means is if you find an article that you find really interesting, you can actually move forward in time as well to all the articles that referred to that article. And that's great for getting around the problem with going backwards in time when you follow the references. So now I've showed you how to find loads of material. Figures like 2,800, 49,000 were coming up there, and then I showed you how to augment that by finding other referenced articles, both backward and forward. So now you've got a ton of literature to get through. How do you, I suppose, discard the literature that you don't want to review? One thing that isn't on the slide is by talking to your supervisor, getting them to find out what they think are the core articles in this area that they're supervising you in, because they're probably fairly expert in that area. So that's one way, but another way of filtering the resultant overload is something we call abstracting. So again, using the article that you had last week, I'll use the software engine this time. You can look at things like the abstract and the title. So when bugs sing, that's not very descriptive, but when you go down to the abstract, you get 2 paragraphs which give you an overview of what the article is talking about, and that describes whether it might be relevant to you. So we describe that as abstracting, deciding if it's worth reading the full article based on the abstract. In this paper we describe how the Caitlin system was used to study the effects of music program oralization. So we're talking about oralizing a program on debugging performed by novice Pascal programmers. If that's your area of interest, debugging, novice programmers, and maybe representation, be it visual or oral, then maybe this is an article worth reading. However, if it's debugging tasks performed by novice programmers without support, without visualization support, then maybe this isn't of interest to you, not as core, and you could discard it. Of course, sometimes the abstract isn't enough. Sometimes abstracts are just badly written, or sometimes, they use lots of words you don't really understand and you feel you just need to read a little more. In that case, I'd recommend that you read the introduction and conclusion and then try to make a decision on whether to fully read the paper or not. This gives you a bit more material to go on, describes what they fully found and what their motivation was, because the introduction is typically orientated towards motivation. So that will give you a bit clearer an idea of maybe whether the paper is relevant or not. Other sources of material include your peers, someone saying to you, oh, I was reading this really good article on, and it might be of relevance to you, and news groups that are on the web. So I suppose the next thing that hits you when you've managed to find all these articles, when you've managed to filter them down to something that's reasonable or plausible that you can read, is to figure out how to read them, how to process all this information. One approach that has been suggested in the literature, a bit frowned on, but I really like it, is this idea of a mapping study, where you essentially map out the main characteristics of the literature in the area you're interested in. So let me take you through the process and give you a little example that might bring it more to life. So the first thing you do is maybe identify an area of interest that you want to do a research review in, or maybe that you want to write a state-of-the-art chapter in for your dissertation. You don't really know where your research question's going yet, but you do know the area of interest. We'll just say software comprehension because that's where my example comes from. You then go to Transparency, find the best evidence in the area. Typically primary papers are found like this, are found by looking in the library with your search terms, looking on Google with your search terms, maybe find very relevant papers, looking at the references of those relevant papers, or looking at other papers that reference them. Both strategies, by the way, are very important, because if you just follow references, you tend to be in one island of researchers who might not refer to other islands of researchers. But if you just use search terms, then you don't get very focused articles impacting or weighting more, weighting, weighting more on the direction of your literature review. So both strategies are important. So you find these papers, you filter out the ones you don't want, and you critically characterize and identify the gaps. So here's where I'm going to go into my example. A lady called Annelies von Marhauser was interested in software comprehension, and she wanted to know what the current state of health of empirical studies in software comprehension is. Empirical studies in software comprehension typically focus on how programmers understand software systems. For those of you in the health informatics class, software systems are very large. They can be tens of millions of lines of code, and they can be very complex with lots of interdependencies and lots of maths type language in them. So it can be very difficult to follow and understand a large software system. Been a lot of work done in this area, and Annelies van Marenhuizen did a mapping study to try and characterize this work, to find research gaps that could then become her research question. And I suppose that's the core agenda behind her mapping study specifically. Mapping studies are to find a research agenda or a research question. So she set up a spreadsheet and she said, okay, well, I'm going to review these papers and look at the maintenance task, the number of lines of code of the systems that programmers are looking at, whether the guy's an expert or a novice. I'll just leave it at that for the moment. And she started looking at different maintenance tasks. Some papers focused on understanding the code, some focused on enhancing it, some people focused on coding it, some people focused on understanding the design of it or debugging it. So there were different maintenance tasks there. Then she looked at the lines of code and she said, oh, okay, so they're typically very, very small system, not the tens of millions of lines of code that we're used to. She looked at the subject's experience and she found that they were typically not experts. And then maybe she said to herself, well, what sort of experimental design was this? God, I haven't recorded that yet. So all of a sudden she said, I need another column to record experimental design or analysis. So she looked at all the experimental designs and she found out that there were vastly protocol analysis. Likewise, she might have decided that she needed to record the purpose, and she might have found this out on the 50th paper. So then she had to go back and record all this purpose information and data design or empirical design information for the 49 previous papers. So over time, the spreadsheet gets wider in terms of the characteristics you're looking at for each paper, and you get more data, one row for each paper, and eventually you begin to see patterns. So you see patterns like, wait a minute, we're looking at very small systems, very small line of code systems. This is not representative of what real maintenance programmers are faced with. You get other characteristics like, well, there's not many expert studies. It's more orientated towards novice, although there are some expert studies. And you look at the programming language they're using and you see that these are all old programming languages, not new programming languages. So using those gaps, she decided her own agenda, which was to study larger systems, to study experts only, and to study newer languages at the time. Now, this is quite an old article, but the newer languages at that time were things like C and Makefiles and stuff like that. So you see the bottom row here is her reply to the gaps that are currently in the literature. I'm going to study a large system, 11 experts, and I'm going to study new programming languages. C at the time. So now she's in this mapping study, she's made the perfect space for her research agenda. All the other guys are doing it on small systems, old programming languages, and to a lesser degree novices or graduate students. So I'm going to focus on the real problem, the big systems that are out there. I'm going to look at how experts do it, because that's probably best practice. I'm going to look at new programming languages because the findings are probably resultant on the programming language studied. So let's look at a current programming language studied. So what she's done after finding these good evidence primary papers is that she's critically characterized them. She's identified an initial set of attributes she wants to look at, made them the columns in her spreadsheet, and she's identified gaps. And as she's gone on, she's actually figured out more characteristics that she should characterize. So she's got more columns in her database. She's revisited all the previous literature, and eventually she's found the gaps in the empirical studies, not modern programming languages, not experts, and not large systems. And she's addressed those gaps by carrying out that sort of study. So this is an iterative process where you introduce new columns, where you get more and more information, when you get better at categorizing things even. And she produced a secondary review of the area, identifying clusters and, more importantly, gaps, thus showing where the literature hasn't gone and where it should go, and thus allowing her the space to carry out her own study, which is reported in the last row of this paper. The first three steps are very close to something called a systematic literature review, which I'm going to present to you in a minute or two, and that'll be though in the next section.